Welcome. This is a prelude to our hands-on training that we will be conducting at an acquired structure with a commercial flat roof. We're going to specifically talk about how to properly vent a commercial flat roof that has metal decking and insulation. Let's discuss this line of duty death that occurred in San Antonio. It was at a commercial strip mall. This is the strip mall in San Antonio. The fire occurred about the center of strip. There are exposures on both Bravo and Delta. They have different depths, as you can see, and also different heights. The fire originated in a fitness center, some about the middle of the strip. Agent 35's lieutenant radioed command and said that there was zero visibility inside the structure, zero ventilation taking place, lots of heat inside the building, and the building has lightweight trusses in the roof. The building construction included a flat metal deck roof supported by lightweight metal bar joists, hidden by a drop ceiling with fire in the attic. Let's go through some of the times. First of all, I want to ask, when you have this situation, what are the hazards? The hazards include fire within a void space and smoke accumulation within a void space. The hazard with that is it can ignite when given a sufficient amount of oxygen if it's hot smoke, causing a backdraft, which can cause an explosion, dropping ceiling tiles, AC duct, wiring, ceiling tile grids, etc., down on firefighters, entrapping them and quickly enhancing the amount of fire. It can also create a flow path if that flow path is not controlled. The solutions are one, identifying the attic fire early by popping ceiling tiles as you make entry into the structure. If there is a ceiling, penetrating that ceiling and looking above the ceiling. This one did not have ceiling on the bottom of the trusses, but making that penetration to check that void space above is important to identify the void space fire before you walk under and past that fire. If it does ignite after you've traveled a good ways in this example, I think it was over 100 feet in before it ignited or spread rapidly, then it can cause a significant hazard for egress and fire control. So this one of the solutions is identifying the problem, getting water on in the void space, and getting a vertical vent to get the smoke and heat up and out, and that prevents it from going down onto the firefighter. So controlling the flow path away from our firefighters and preventing that accumulation is imperative. What do we not want to do? We do not want to bypass the fire, and we do not want to provide air to it. So let's just go through a few key things that occurred, and there's plenty more. You can read the line of duty death report to get more details, but just to give you somewhat of a time frame, in 21:17 hours, Ladder 35 was on scene, and they went interior to look for the fire. 21:22, they called a working, command called that they had a working fire, heavy smoke. They had a crew on search, a crew on attack, another one checking extension on exposure delta, and they had another engine in division Charlie. So they have several units on scene, basically looking for the fire. They never did give a smoke read with details as to volume, velocity, density, color. Typically, an attic fire is evident from the smoke read, especially when you compare the smoke read from the exterior to your first look on the interior. And then once you make an interior inspection hole into the attic space above the ceiling tile and then above the ceiling, if there is one, that ceiling to roof report provides additional information so that command and other units have a much better idea of where the fire is and where it is going. At 21:23, platform 32 arrived on scene. That's 5 minutes later. Then another minute after that, ladder 35 found fire in the attic. These, the firefighters on there were not on a hose line. They were doing search and they were popping ceiling tile. So they exposed the fire and made a call that they found the fire. It's in the attic. And shortly after that, they're calling fire through the roof because this flow path has been created. We've gotten air to the fire. It starts to grow rapidly. The fire in the caulk loft is growing, and there's an order to open up the back door and to evacuate all the personnel inside at 21:27 due to this rapidly changing fire conditions. At 21:29, the personnel on ladder 35 that had opened up that attic space were calling Mayday, Mayday, Mayday. And we ended up with a fatality from this incident. One other note is they did have positive pressure fans on the structure, which was feeding air into the void space because there was not a sufficient exit. There was an open back door, but with the fire being above it, the only place for it to go is with forced air is back down as opposed to out the door and up and away without a vertical vent. So keep that in mind. You've got to have a vertical vent for an overhead fire. Yeah. Another similar fire occurred in Bryan, Texas at the KFC Hall. The structure was had a flat roof on the portion where the fire started. It had basically it was in a kitchen and there was an open grid and drop ceiling where the fire spread into the void space. Firefighters made their way across an open area to the kitchen not knowing that the fire was above their heads. When they got in the kitchen, they put water on the fire. Felt like they were doing pretty good. They had fans on the fire. They did not have a vertical vent. And as the air mixed with the existing fire and smoke, and it began to spread and intensified overhead. I do not believe they pulled ceiling tiles, but it burnt significantly enough to expose itself back down into the um, the big open hall area, which was on their means of egress, or at least the egress that they chose because it's the way they came in. There was another door near the kitchen that led out. So we have no vertical vent, flat roof, overhead fire that they did not expose, did not identify, and they pushed air into a confined area with ignitable smoke. We know smoke is fuel, and hot smoke needs air to ignite, which can cause a backdraft. Even if it doesn't cause a backdraft explosion, it can significantly intensify. Same results, just a little bit slower. So egress was cut off. Two ended up dying, and two more severely injured in the Bryan Fire Department. In Memphis, 2003, we had two LODs. I'm just going to read this. On June the 15th, 2003, a 39-year-old male career lieutenant and a 39-year-old male career firefighter died while trying to exit a commercial structure following a partial collapse of the roof, which was supported by lightweight metal trusses. The victims were part of the initial entry crew searching for the fire and possible entrapment of the store manager. Both victims were in the back of the store operating a hand line on the fire that was rolling overhead above a suspended ceiling. A truck company was pulling ceiling tiles, searching for a fire extension when a possible backdraft explosion occurred in the void space above the ceiling tiles. Some of the common factors in all three of these fires are we have fire in the void space above the firefighters' heads, and they are pulling ceiling and adding air to that fire without a vertical ventilation. And most of these fires occurred 10 to 15 minutes after the scene time, and there still was not a vertical vent cut. So here's the question: can you right now get a substantial vertical vent hole cut in a commercial flat roof in a timely manner and safely? By the end of this class, I would like to think that we're all going to be able to do that. Ventilation can be a critical function on the fire ground. It can prevent backdraft, flashover, dangerous flow paths, accumulation of toxic gases, and or collapse if performed correctly. Some vent jobs may be too risky for firefighters, and without a controlled vent, we are left without a controlled flow path. Some difficult vent jobs can be safely performed, but only with good techniques and proper training, which we intend to provide. We will teach you how to reduce risk and still perform a higher risk vent job on commercial flat roofs. Now, flat roofs buildings are extremely important to train on because fire behavior is different, ventilation is different, and firefighters tend to treat them as they would a house fire by mistake, which has the potential to cause injuries and or death of the firefighter. These are some educational standards. We're going to make a ventilation hole large enough to exhaust the amount of smoke necessary to reduce the hazards below the roof and or ceiling level. We want to provide a quality roof report. We want to learn a systematic technique that can be repeated and will improve safety and efficiency. We're teaching a process, not just the skills. Understand the who, what, where, when, how, and why of this specific fireground job and perform the tasks to a minimum standard. Our objectives are understand the hazards of roof work and the potential benefits, discuss some common flat roof vent techniques, evaluate the risk, incorporate risk reduction measures, access the roof, provide a roof report, determine where to cut an inspection hole, decide how to cut, and practice insulation removal for a two-step cut, and practice performing cuts on a flat roof with metal decking. Safety briefing. I don't want you to do anything that you're not comfortable with. If you have not handled a saw before or very, very little, it's something you may need to practice more before getting too in depth into cutting some of these more difficult holes. Yes, you will get saw time, but just understand that if you're having trouble with the saw, we may not have enough time to go back to some of the basics of saw handling. You may have to go back and work on that at the station level. You're gonna have to wear your bunker gear, eye pro, helmet, ear pro, dust masks, and gloves. Don't cut yourself with the saw. If you can't operate one comfortably and safely, you will be allowed to do everything except cutting, but we will pull you off the saw. Don't get your feelings hurt. Go back to your house, home station, and practice. Don't drop the saws. Don't cut the trusses through and break the chain. You're going to bump them, you're going to touch them, but you need to learn to roll them gently without forcing the saw into them and damaging the chain. That can take you out of commission. Don't cut your friends. Be careful with the saws and know where they're facing at all times, and make sure you have positive footing and good control of your tools. Always run your saws at full RPMs when you're cutting, and then let it slow before you change the direction of cut. Now, dead blading, rotary saws is the standard, but since we're going to be doing this over and over and over, I do not want to damage our saws. So instead of dead blading, we're going to let the RPM slow down. Once they've slowed down substantially. You can finish it with a dead blade, but I don't want you dead blading at full RPMs and rushing. We're going to go slow and not damage our equipment in doing so we can still get all the tactics skills performed, but we don't want to damage equipment in so doing. Now, also, don't fall off the edge. We're going to keep a 6-foot no-go zone all the way around the roof, just like we would in rope rescue. You have to have fall pro if you're within 6 foot. On flat roof, we're going to keep a 6-foot no-go zone. Of course, if you're laddering, you have to be within that 6 foot. But as we're working, especially when there's smoky conditions, it's nighttime, you can't see well and all that, we want to try to stop before we get to the edge of the roof. That last 6 foot is not going to be imperative to our successful ventilation. So we're making that a standard. So how are flat roofs different than the standard peaked roof that we would normally cut on a residential structure fire? Well, I'm glad you asked. One, you have overhead void spaces. And there may be multiple. Like I talked about before, you could have a drop ceiling and then a ceiling on the bottom side of the trusses and then a roof. In addition, sometimes you'll have a roof built up on top of the old flat roof. These suckers leak over time and they get them redone and redone and redone. And at some point they're like, hey, let's make this thing slope. What a novel idea. So the water will run off the roof instead of just sitting there. And at some point when a crack develops, come through. So they'll make a slope to them. Usually it's a shed. Usually it flows to the back. And it may look like a flat roof, and then you hop up there and you see that there's no parapet up front, but there is towards the rear because they have sloped it. So now you've got to determine, well, how deep is that, and can I make a double cut and get this safely done, or am I going to be putting a firefighter down in a hole in a dangerous situation? So there's a decision that has to be made at that point. Can you do it? Can you not? And do you have to move maybe further towards the Division Charlie in order to get it done because the secondary roof is too tall? Now, is that going to draw fire? Is it way too far away from the seat of the fire? Or is it going to be okay because you'd rather burn up some of the attic and get some of that pressure off for your firefighters inside? There's a lot of things to think about. We're not going to get into how to make all those decisions right now, but we do need to understand there could be more than one overhead void space in that attic, and that they can oftentimes be common attics across multiple suites of a row of stores, for example, which is a cockloft. Various truss materials from one area to another. For example, a portion of a building burns, they replace the roofing, and it was wood frame, and now they put in metal frame. That could go for not just the framing, but also the decking material, the insulation, the moisture barrier. You could have completely different roofs that they tie in together from one suite to another, one section of a building to another. So you don't know for sure that it's always the same construction. We can assume that it is, but it's not necessarily. Long spans may be difficult to predict collapse, just because we don't know, is this one truss that goes all the way across this building? Is it broken up into other trusses? Has it well engineered? Did they make sure that they had enough height and strength of those trusses when they designed it, or is it under design? Have they added extra load to it? How long has the fire been impinging upon the structural members? If it's wooden, they're eating away. If it's metal, they're starting to heat up and sag and weaken and can collapse. So we need to make our best judgment as to the strength of these long span trusses, which are oftentimes open, which means there's a lot of surface area exposed to the heat. They're thin members, and therefore they react negatively fairly quickly compared to a solid beam or board. On a flat roof, our egress routes aren't down like they would be on a peaked roof, which you're going down, you're going towards stronger material almost always. But typically it's going to just be the nearest wall, depending on which side of the vent hole that you're creating that you are. You may have guys running different directions to what is the nearest wall for them. Therefore, having egress ladders or egress points all the way around the structure are important. Thick insulation may be difficult to predict collapse. So sometimes you're walking on those and you can't feel how strong that roof is. Sometimes they're a little bouncy, sometimes they're not. Sometimes, that thick insulation just muffles um, your inspection of that roof. And that inspection includes not just hitting it with your tool, because you really can't hear it, but you can feel it, which is great if you have plywood decking or shiplap decking. You're pounding it and you're feeling a solid object. But when you're hitting insulation, which is soft, you're not really getting much of a return. So basically, you can kind of heft it with your feet with a heavy step, or kind of bouncing a little bit on that roof, and see how much it shakes. That's going to give you more information than hitting it with your tool. Typically, hitting with your tool is still advised to check a point inspection. Hopefully your tool will not go all the way through, especially if it's metal decking. That's just not the way it's going to collapse, right? And that's what we're primarily talking about. So we're doing basically a shake of the roof. Typical construction of a flat roof may be of various materials, the most basic of which is wooden rafters. As you see in this picture, the rafters can span all the way across a room, or in this situation, you see that they have a metal framed post that is supporting those rafters. Sometimes, like in this example, an unreinforced masonry building, they could be put into the wall. Other times there will be posts or a ledger board or something like that around the walls. Wood frame flat roofs almost always have plywood decking, and then they have potentially some type of insulation, but then they have some type of water barrier, whether that is tar and gravel, rolled roofing, and or layers of all this stuff. It could be some elastomeric type roofing, such as TPO or something else. And again, it could be multiple layers. They usually do not have as thick of insulation as newer buildings, in which we're looking for higher R values to reduce AC costs. So this is basically the same as a residential when it comes to venting it, except it's flat. So we're going to we're not going to cover that in this class. You're going to cut, louver, and open up the roof just like you would on a peaked roof of a residence. You could have open web wood trusses, which again are about the same. We're going to almost always have wood decking on wood, whether it's solid or open web trusses. Therefore, again, we'll cut through the plywood, we'll roll the rafters, we'll louver it, we're going to get a vent opened up, and it's virtually the same as residential construction, except it's flat. So easy peasy. We're just going to knock that out and get off the roof once we know that we have a substantial amount of lift. There's just a little picture of some wood decking on top of some trusses. Now we got some other construction. We got that red iron I-beams with purlins. When we have the purlins for a metal frame structure, almost always it's going to have metal roofing, and the metal roofing is going to be screwed onto the purlin. So you can just look at the screw pattern and see exactly where the purlins are. You can cut in between there towards the top, and you're donesies. It's too easy. You just want to make sure that you start at the top and stand below the next purlin when you're finishing that hole out, so you don't risk falling through. Remember where the supports are and get on the opposite side of one when making that cut. Again, we're not going to be teaching this technique today. I just taught it to you because it's pretty easy. Here's another one, I-beams with a big building, very long span. It's got a little bit of a pitch to it. Again, same thing. You've got purlins, you've got screws. You can see where to cut. Too easy. Cut it, turn it, drop it. And I say turn it or drop it. I don't know if I'd want to drop it if I could help it. We really try to turn and pull if we can, just so we don't drop it on our friends below. We do need to let them know we are cutting and communicate with fire attack below when we're cutting anything that has metal that could come down on them, so they can position themselves, hopefully in a position where they're not going to get hit with it, just in case. All right, here's some bar joists that run from wall to wall, just from front to rear. Most of your older and smaller strips, taxpayers, row of stores, whatever you want to call them, the trusses will run from Alpha to Charlie, and they just go from wall to wall. But then when you have bigger structures, and you can't run your trusses that far, they'll have a big truss, and then they'll have the smaller trusses that run off of those, and they'll basically run from column to column on the big trusses, and the smaller trusses will span out from there, and they'll grid that off as many times as needed to cover the store. So that's a very, very common one. So you may not know exactly which way they run on any bigger store. So we have to make an inspection cut to find those. The span that a metal bar joist can reach varies depending on the construction somewhat. However, there's a range from 10 to 15 times the height. The taller something structural member is, the further it can reach unsupported. So 10 to 15 is actually similar to what we utilize for structural collapse rescue. We utilize 1 inch of height to 1 foot of span, so which is a 12 to 1, which is right there in the middle. So if we have a car go through a structure or whatever, we have an 8 foot hole and we need to support that, we need a header that is at least 8 inches high to span 8 foot across. So that's fairly easy to remember. Now, the spacing in between them will vary as well. It all depends on the load. Is there going to be a static load on there of AC units and other things, solar panels, or who knows what? Also, what's the dynamic load? What's the wall height? What's the wind load? Are you in a hurricane area? Are you in an earthquake area? All that kind of stuff plays into it. But just looking at buildings around our area, I noticed that 6 foot is very common, and probably are the vast majority range from 4 to 6. We're definitely going to know once we make the cut, but we can expect our next truss to be somewhere typically between 4 to 6 foot over. Here's another example of one. It's a pretty big structure, so they have trusses running both directions. However, all the metal decking is running in one direction across the trusses that are running Alpha to Charlie. All right, I already covered this, but here's an example of a strip that's not very deep from Alpha to Charlie on one section, the section on fire. So you can pretty much be, pretty certain that the trusses are going to run from Alpha to Charlie there, but then this section over here towards the Bravo is a little bigger. It may run Alpha to Charlie or Bravo to Delta. I don't know. We'll just have to make a cut and see. And we'll talk about that a little later. Basically, I'll have to say it real quick right now. If we think they're running from Alpha to Charlie, we'll make our first cut Bravo to Delta, side to side, so we can find that truss. That's what we're trying to do right off the bat. First cut, find a truss. And if we don't know which way they run, then we'll cut at a 45, because at some point, no matter which way they run, we're going to find one at our 45. And as we find it, we'll roll the truss, the very first truss, and make our inspection cut at that point, and then we can start our hole. Okay, we finally get to the actual procedure for performing the vertical vent step-by-step process. Step 1, we have to assess the building. What's the overall size of the building? What's the height of the walls, the anticipated roof height, ceiling height, volume on the interior? Is it compartmented or not? What's our access, placement, hydrant locations? Is there access all the way around? Can we get that 360-degree assessment? And we're getting a good idea of what we're dealing with as far as the building, and simultaneously we're reading the smoke Volume, velocity, density, color, where's it coming from and where's it going? That's what it's going to tell us. We're going to compare like size openings, consider wind, consider everything else, and we're going to have a good idea where the fire is and what it's doing. So at that point, we can make a pretty good decision as to what we need to do as far as ventilation. We want to control the path that the smoke and heat goes to because that helps us control the fire. It prevents all the bad things that we've talked about. And if we can do that with a vertical vent on a flat roof, typically you're not going to be able to do horizontal real well because a door height is 7 foot tall. On commercial buildings, ceiling height is often well above that. Therefore, heat and smoke is accumulated above your head height or door height. So all you're doing is adding air in one side and out the other and creating a churning effect. So you're adding air and turbulence to the smoke and fire. It's usually a negative effect that occurs. If you happen to have 8 foot only ceilings, it is a viable option, but excluding that, we typically are just going to go vertical because it does what we need to do in getting the smoke up and out. So command calls for vertical ventilation of a flat roof building. Here we go. Now that we know the job, we've got to get up there. How do we get up there? We're either going to utilize ground ladders and or an aerial ladder. Depending on the situation and how big the job is, I prefer aerial for carrying a lot of tools. Um, but we need to place it in a location that's going to be close to where we're going to cut, so there's less travel distance across the roof, and um, make sure you have good footing and follow all your typical procedures for your placement of that aerial. And that's now your routes of egress and or additional tools and potentially additional companies coming up to help as well. So that's established. We get on the roof. We need to provide a roof report. A roof report is imperative because on a flat roof, as opposed to a peaked roof, the incident commander can't see what's going on up there. He can't see, he'll see the smoke 10, 20, 30 foot up in the air where it's visible, but he can't see it at the point of discharge. So he doesn't know whether it's coming through holes in the roof where it's burnt through. He doesn't know if it's coming through natural openings, if it's broken some windows or glass or what it's doing. He doesn't know if there's loads up there on the roof. He can't see, therefore we have to provide that information. So we're letting him know the integrity of the roof. Is there sagging anywhere? What is the material that we see? What are the smoke conditions that we see? Loads, etc., any type of hazards. And once he has that information, then he and everyone else on the fire ground can better perform their jobs. An example would be we've had crews almost crushed in a collapse. Thinking of Casa Ole is one of them, in which the rooftop AC unit is heavy and it provides a lot of weight and it's coming down. If someone were throwing a ladder and got a roof report pretty quickly, they can say, oh man, we've got some sagging here, and may be able to get people out from underneath a potential collapse before it occurs. That could be a life-saving report. So don't neglect to give the roof report from whoever is first up there and has eyes on that situation. Next, we need to pound that roof or heft the roof, shake it a bit to get a general idea of the integrity. A flat roof, especially if it has insulation, it's much more difficult to get that feedback that you would if it were a shiplap or plywood decking like you would on a residential. Of course, that's more solid, so you can pound it, and we typically have a fairly good understanding of what that should feel like. But with the insulation dampening our blows, we have to basically jostle it around to give us the best feedback that we can. Okay, we need to cut an inspection hole. That's when it comes to cutting, that's the first step in our process. The question is how, where, and why. The why is we need to know what materials we're dealing with and how thick those materials are. The type of materials lets us know which saws are going to cut through it the best, and maybe some false positives, such as when we have that lightweight concrete, it's throwing out dust and it looks like smoke's coming through. It's not really smoke, it's just dust. Well, when we do our inspection hole, we can identify that. When we have insulation, we can tell if it's 1 or 2 layers, how thick it is, and various other things. So we need to know, will our saw cut through the material? And remember, when you do this, the cut, I say do a triangle about 18 inches and make sure that you overlap the corners. We overlap them because it's the center shaft or the flange washer, the center of that flange washer, that is going to be at full depth cut. But as the blade goes forward, you can see around this circle, um, it's not cutting all the way through. This is the only point at which this blade is cutting all the way through the material, so it's near the center. Therefore, our overlap from what we see as the cut needs to be about 7 inches. It depends on the material, but if we're having to do a full depth cut, 7 inches away. If we're cutting this deep, 6 inches away, 5, and so on. That's why I typically just do my hands like this with about at least a 4-inch overlap, to make sure. If you can feel it too, when you're cutting through the metal or you're not. If you're just barely getting all the way through, obviously overlap your intersecting points a little more than you normally would, um, for a thinner uh, amount of roofing material. So we want to do that and capture that material so we can see what it is. I just did the how, and the where. The where is, I'm going to say 2 different options. If we have a flat roof with a tremendous amount of fire involvement and smoke pushing out around the perimeter all the way around us, we're going to be going somewhere in the middle of this roof assembly, yet we know that the smoke at least has progressed well past where we are, and we feel like, hey man, I don't know what materials are in there. I don't know what the integrity of them is. Let's get an inspection hole cut close to the point at which we access the roof, out of our means of egress, just to the side. Let's cut that right here, right now, and get an idea. We'll also see how much smoke pushes through that cut right there at that point, which is a likely egress point for us, since it's the first and only ladder that we probably have on the building at this point in time. We know what's going on there, and we can monitor that from that point on. Um, Make our decision that we're going to go ahead and cut this. I think it's just smoke. There's not fire involvement. I don't feel like the metal or wooden trusses are deteriorating. We can get out there to the middle and we can make this cut. Let's go. And then we go start our cut. If we're going to go straight to the cutting point in the center, and we're comfortable with this roof, let's get over there. It feels good. I'm hopping on it. We're going to go make that cut right now. Then I would do my inspection hole at the point of the cut, because we can just transition from that into the rest of our cut. So if we feel like we know the trusses are running in a specific direction, like say Alpha to Charlie on a narrow, long structure, then we're going to make our first cut from Bravo to Delta perpendicular across there, because we want to find a truss and roll that truss. That way we get we identify the location of our first truss. Yay, number one. We hit it, we roll it, we don't damage our equipment, we roll past it a little bit, and then we cut our triangle over that truss. So our next 2 cuts are over the truss again. That way we don't lose that material. And even if we happen to hit it right where a weld spot is or something like that, we've cut the material, but we pull out everything except the metal, we can look at it and see that we're dealing with this type and thickness of metal decking, B decking, for example, and this much insulation, etc., and then determine whether or not our rotary saws will be able to cut all the way through or not. So that's going to be imperative for the next step. We have to know the depth that our saws cut with the blades that are on them, and compared to the depth of the material, because we want to do one of 2 things, and that is, we either want to cut all the way through the material, or we want to cut only through the insulation. Here's a picture just so you can see how they stack layers of foam insulation sometimes to get more insulation or more depth, or sometimes they'll do it to create a slight slope so the water will run uh, to roof drains either on the edge or the middle of the roof. So you may have different thicknesses. This is probably at least 2-inch foam, 2, 4, 6, 8, at least 8 inches of foam at this point. Maybe 12 inches if that's 3 inches thick. So just know that you can come into a big fat hamburger that you know you're not going to be able to cut through with one cut. Here's a look at your saws. It's important to know your saws and the depth of cut, not just which blade you have on there, but also look at the guard. For example, the guard on the left, there is still a little bit of space. So the 2 points that are touching are the back of the guard and the foot. That could be tilted forward and on the WLC blue blade and maybe get a little bit more depth there. And that could be the difference between penetrating and not. So the position of the saw in your hands as well as the position of the guard. Is it all the way back, or is it back so far that that extra little bit is from about a 1/4 inch of cut? When you look at the saw on the right, you'll see that the guard is in line with the foot better. So when you lean it forward and you're touching the outer portion of the guard, you can cut to full depth of the blade, which on a real roof only gets you to the disc, that big fat washer on there, because it's so thick it won't push through. Um, Again, the simplistic version is this blade isn't as big, it doesn't cut as deep, but there are some other things that you need to pay attention to, which is the where your guard is and the angle that you hold your saw at, and that can change as you cut, and that I have seen that be one of the reasons why someone cuts all the way through the material and then misses some spots here and there, because it's changing as you step and drag. Just keep that in mind. A quick note on saws. When cutting the inspection cut, or our first cut, if we're going to go straight towards the center, I would prefer the chainsaw because it has the deepest cut, and I know I can cut out my inspection cut one time effectively and not have to go back and recut because my blade didn't cut deep enough. So that's a lot of wasted time to have to go back and retrace your cuts, and we haven't even got the job started yet. We will talk about some techniques to limit the damage to your chainsaw, but of course it has to be a carbide tipped chain, assuming that we're going to have metal decking on this flat roof. Now that we know the depth of cut, we can make the cut plan. The cut plan is pretty simple. It's either a 1-step or a 2-step cut. We can cut all the way through, go quickly. Hopefully we can utilize a chainsaw and do that 1-step cut as long as possible. And if it is deep enough that we have to do a 2-step cut with rotary saws, then we'll transition to that as needed. Now, another thing we need to think about, this should be on our gathering tools and equipment, and or say we get a second company, we may want to ask for some additional equipment. Of course, we know we need hook saws, as many saws as possible with extra chain, maybe even a bar and chain. We need some box lights because with the box light we can mark our egress from our ladder point. We can mark where we want to cut. We can use the floodlight to just light up the work area. It has both a flood and a spot, so we can point with it, and we can light up the area as needed to prevent, some areas where we might trip or step off the end of the roof or whatever it is. So lighting is good. So is the ladder. Make sure your ladder's set up with some lighting and they're turned on. We've got to coordinate with fire attack and the incident commander. One way we can do that is with our light or a hook sticking over a parapet or the edge of the roof. Tools. Other tools, maybe shovels or a plethora of other things, just knowing that we need a lot of stuff up there. Another one might be cylinders. We run out of air. Going all the way down the ladder just to change out an air bottle is very time consuming. So if there are free hands that we could throw towards this job, which there very seldom are, air cylinders may be another item that we can uh, have on the roof stage, maybe over at our access point that we can change out quickly and go back to work. Step 6, we're extending our cut now. We made our first hole, 4x4, 6x6, 5x5, whatever it is, somewhere around there typically. Now we're going to extend the cut. We're running inside the trusses, cutting down. Somebody's making a cross cut while the other one's doing their extension. So we're kind of just leapfrogging each other. And I would stick with my cross cuts being approximately however wide the trusses are apart. If they're 6 foot apart, we're just making 6 foot squares as we extend these cuts. It keeps it simple. We want to make sure our bodies are on the outside of the trusses. Make the cross cut before the center cuts are brought all the way to it. That way you're standing on solid material. And then in addition to our 2 cutters, somebody's got to be catching that material. So we have a turner or a puller. That could be our 3rd and or 4th firefighters. So if the material is starting to sag, we need to hold it level so the saw doesn't get caught. And also when we get to the last foot to 6 inches, I feel like they need to start lifting up. We could pull the saw out, and we're going to coordinate this based on the material, the thickness of the insulation. You've got various gauges of metal, all kinds of things to think about, but once we make our first turn, we'll kind of see where that point is, and we'll learn how to turn that without dropping it through the hole, hopefully, and we'll practice that during the hands-on section. Our preference is to pull the material. If we have to let it fall through, then we will have to let it fall through. We just need to warn the firefighters below that there could be falling debris, including that metal decking, which is sharp and could definitely injure someone. But if you remember the importance of the vertical vent, preventing backdraft, flow path, flashovers, structural collapse, and all these really bad things, we've got to decide, is the benefit worth the risk? If the guys are like, hey, yeah, we can step over here and still hit the fire and be well away from where you're cutting, then let's drop it. That's another way in which fire attack can coordinate with vent to limit that risk. But again, we're trying to pull it if at all possible. We'd really want to watch out that can look for hazards, fall hazards, trip hazards, maybe even make some curve cuts if there's an available saw to be able to see the smoke and the fire progression. And they should be reading the smoke around the perimeter constantly. So there should be smoke on a flat roof, usually from the roof as well as from the outside of the roof. And make sure you distinguish between those two, because that smoke coming from the outside of the roof, which is coming out of doors, windows, plate glass, whatever it's coming out of, um, as we start to make our cuts and get some pressure relief, that other smoke should diminish and our smoke should increase from the controlled flow path up and out that we're making. So we got to watch that pretty carefully. And that's part of step 8, really. We want to extend that cut until we see that desired effect, which means we're reading the smoke and we're seeing positive changes. In addition, we can call that on the radio to incident command, and they can confirm from their perspective, safety's perspective, the division, Charlie, um, supervisor, or whatever it is, people on the exterior that are watching these things carefully. They can say, yeah, you do have good positive changes in smoke conditions. You've done a great job. And we can, terminate the roof operations at that point, hopefully. Some flat roof vent failure points include being too slow. Too slow is relative. Um, we can set some times, but it does take a little bit longer. We want to move as fast as we can without falling, tripping, without being able to mentally understand the hazards associated with the job, performing a good risk assessment, and putting ourselves in danger, but as fast as we can without doing that. So that's different for different people. However, we may be able to set an actual time at some point, and again, it's all relative, but we have to go as fast as possible. People that are just lollygagging and completely ineffective at their job, that would be a fail to the time standard. Obviously, you're a failure if you fall through the roof, and nobody needs to say anything to you because you're going to feel it if you live. Same with falling over the edge. Just don't fall over the edge. We can't afford to injure a firefighter for a structure. The odds are we are fighting a fire in which we are only saving a structure. It's not worth dying over. We don't want to die in a commercial fire. Most of the time, the companies don't even care about the structure. They're just going to write everything off and rebuild it anyway. So keep that in mind. Daytime commercial fire, people are almost always out. There's not a high rescue profile, and we're literally saving property. And that property, if well involved, is already written off before we even make entry. So include that in your risk assessment. We don't want to destroy equipment if it can be prevented. We're always going to tear up some stuff here and there, but I've seen dudes tear up stuff just for no reason other than they're inexperienced and have no control over their tools. So if it's just, just lack of being able to perform well with their equipment, then that's a fail. And then if we're making the roof without necessary equipment, basically we just leave it on the ground. That could be a fail if it's something that we really need. And granted, you can't carry everything, right? You're going up a ladder. At what point is it too dangerous to carry stuff versus not have a hand to grab a rung? Depends on how tall the roof is, how steep is that ladder. All that kind of stuff plays into it as well. But we don't want to, if we have to make an extra trip, we got to make an extra trip and or call for some reinforcements to help us to get our stuff up there. Some guidelines. Guidelines are things that are kind of keep us in bounds. You have some latitude left and right, but where is that line? So roof access, it may be by a ground ladder or an aerial ladder. For the most part, 2-story and below, on most structures, I expect a ground ladder to be thrown because you can get up there and cut a hole quickly. If all you're having to take up there is a chainsaw. However, on a flat roof, when we're carrying multiple saws, backup equipment, hooks, and maybe a light at night and other equipment, like, replacement chain, etc., scritch, whatever, we're carrying a lot of stuff up there. At that point, it may be, and I think it is, more valid to have the aerial set up while we're getting all this equipment ready. And by the time the aerial is in place, we're ready to shimmy up, but we can more safely access that roof with more equipment and not have to be grabbing the rungs. We can just run along the rails as we're zipping on up. And of course, if we're in a tower ladder or platform, we can load the bucket with a tremendous amount of stuff and keep going, including a couple extra bottles for our SCBA, because odds are we're going to run out of air at some point during this job, and going back to the ground is very time consuming. If we can have extra bottles, we can keep on going. So basically, we need to use whatever we feel like is the most effective means for the situation. Chainsaws, they do have the deepest cut. We do tend to break them easier than we do rotary saws, but for our initial cut to check the depth, I feel like we need to use a chainsaw. So we have to have it on the roof ready to rock. And if it's iffy, like say we may or may not be able to cut all the way through with a rotary saw, not if we cannot, excuse me, we know the chainsaw can, so let's run that chainsaw safely and not so fast that we break it, but run it as long as we can. And once it's broken, then we can switch over to the rotary saw. Just because it does such good work, in my opinion. A single cut is way faster than a double cut, is my point. So don't waste time doing a double if you can do a single. All right, I'm going to summarize this training class. Commercial flat roofs can pose a significant hazard to firefighters if the hazards aren't managed appropriately with sound basic assessments such as understanding how to read the structure, read smoke, and understanding fire behavior. We can make plans to effectively attack the fire or call it a defensive attack as appropriate. The vertical vent aspect of the job can be an integral part of making that decision because it can save firefighters' lives if performed quickly and efficiently. However, it can also be a dangerous job due to falling through the roof, off the roof, etc. Yet, we can manage those risks by properly assessing the job and making our cuts from a safe location and in a timely manner. If we are well trained and efficient at our job, we can provide a safer work environment for the firefighters on the inside and prevent those major hazards of backdraft, flashover, flow path, collapse, and the accumulation of toxic smoke. If you have any questions, please contact me or your training cadre, and hopefully we can work out any confusion, if there is any, when we go to the hands-on section.